Hi guys, in this video we're gonna see the solution of the practice problem 11.4 from the textbook Fundamental of Electric Circuit by Alexander and Sadiku 6th edition. So the problem is asking to calculate the average power absorbed by each of the 5 elements in the circuit. They are A, B, C, D, and E. But before we get into the calculation of the average power for each component, first we must know the amount of the current flowing in the circuit. So we use mesh analysis to solve it. This is mesh 1. Mesh 1 is current flowing through is I1, and this is mesh 2. And for mesh 1 is minus 40 at 0 degree phase angle plus 8 multiplied with I1 plus minus J2 multiplied with I1 minus I2 is equal to 0. So we got minus 40 plus 8 multiplied with I1 minus J2 I1 plus J2 I2 is equal to 0. And we divide this all equation with 2, and we got minus 20 plus 4I1 minus JI1 plus JI2 equal to 0. And we change the format as JI1 plus JI2 is equal to 20. This is the equation 1. Now we go to the mesh 2. Mesh 2 is J4I2 plus 20 at 90 degree phase angle minus J2 multiplied with I2 minus I1 is equal to 0. So we got J4I2 plus 20 at 90 degree phase angle minus J2I2 plus J2I1 is equal to 0. And we divide this. We're gonna change it into a complex form. So we got J4I2 minus J20 minus J2I2 plus J2I1. And we're gonna divide it by 2. And we got J2I2 plus J10 minus JI2 plus J2I1. And we got JI2 plus JI1 plus J10 is equal to 0. We got JI1 plus JI2 is equal to minus J10. It is equation 2. And we take the elimination to get the I1 and I2. There is 4 minus J multiplied with I1 plus JI2 is equal to 20. And the equation 2 is JI1 plus JI2 is equal to minus J10. And we took the elimination, and we got 4I1 minus JI1 minus JI1 20 plus J10. And then we got 4I1 minus J2I1 is equal to 20 plus J10. Because it is in a complex form, we're gonna make it into a polar form to make it more easier. So I1 is 4 minus J2, 20 plus J10. I1 is, this is change it into a polar form because we got 20 root at octangle minus 0.5 is minus 0.5 is minus 26.56 minus 26.56 degree equal to arctangent 0.5 is 26.56, and we got I1 is I1 is 5 at 53.12 degree phase angle. This is the I1. We can make it into a compact form, and we got I1 is 3 plus 4G. This is the I1. Now we find the I2. I2 is, we use the equation 2 for find the I2. Ji1 plus Ji2 is equal to minus J10. Ji1 is J multiplied with 3 plus 4J plus Ji2 minus J10, and we got this J3 minus 4 plus Ji2 minus J10, and we got this J13 minus 4 minus Ji2, and then we change it into power form, and we got 13.60 at minus 72.89 degree phase angle equal to 1 at minus 90 degree phase angle. So I2 is divided by 1 at minus 90 degree phase angle, and we got the I2 is minus 13.60 at 70.10 degree phase angle. And now we can calculate the average power absorbed by each of the 5 elements in this circuit. So first we're gonna calculate the first element. The first element is A, so PA is 1 divided by 2 Vmax Amax cosinus theta V minus theta I. So 1 divided by 2, Vmax is 40, Imax is 5, cosinus theta V is 0, minus theta I is 53.12 degree, and we got cosinus minus 53.12, we got 0.6 multiplied with 100, and we got 60. That's 60 kilowatt, and this is the result. But the PA is a negative value. It's a negative value. Why do I write is minus here? Because the power at the voltage supplies power to the circuit, so it has a negative value. Next, we go to the second component is B. Second component is resistor, so PB is 1 divided by 2 V resistor multiplied with I resistor. We know the V resistor is 8 multiplied with I1 is 8 multiplied with 5. We got 40 volt, and we got the value 1 divided by 2 multiplied with 40 multiplied with 5, and we got 100 kilowatts. And now we go to the third and fourth. P3 and P4 is 0 kilowatt because the power through the capacitor and inductor is always 0 kilowatts. Next, we find the flux component. P5 is 1 divided by 2 Imax Vmax cosinus theta V minus theta I, and this is 1 divided by 2. Imax is I2 is minus 13.60, Vmax is Same x is 20 multiply with 20. Cosinus theta v is 90 degree minus theta I is 70.10 degree. And we got cosinus 72.9 is 0.29 multiply with 20 multiply with minus 13.60 divided by 2. We got minus 39.96 minus 39.96, and it is the same value with minus 40 kilowatts. And yeah, this is the solution of the question to calculate the average power absorbed by each 5 element in the circuit. I hope you will understand it and enjoy it. If you guys still confused about this question, you can ask me in the comments column below. Thank you.